Alright, so we're going to do the third part of parametric equations today, and then that consists of example number 9 and example number 10 in the book on page 480 and 481. So let's look at example number 9. In example number 9, we have Kevin hitting a baseball 3 feet above the ground with an initial speed of 150 feet per second at an angle of 18 degrees with the horizontal. Will the ball clear a 20-foot wall that is 400 feet away? So we have hitting the ball at 150 feet per second, 150 feet per second at an 18 degrees angle here, which means that we can now say, we can decompose this vector here into a horizontal and a vertical component. The horizontal component here would be 150 times cosine 18 degrees. And up here, the vertical would be 150 sine 18 degrees here. Okay? So those are, so you have an initial velocity in the x direction, initial velocity in the y direction. So if you remember, we said that the y, when we were doing free fall, the y was equal to negative 16t squared plus v naught t plus s naught. Okay, so in here, the v naught in the y direction, the initial velocity is this guy here. Okay, so this can further be t squared plus 150 sine 18 degrees t plus the initial height. The initial height was 3 feet, so 3. So in the y direction, this is what it's going to look like. Now what's happening in the x direction? The x direction, you're going this way. So in the x direction, you are 150 times cosine 18 degrees. What else is that? So in here, in the vertical direction, you had gravity that was working against you. And that was represented by this guy right here. Okay. Now on the x direction, there is no gravity. There is nothing actually impeding or helping the velocity. So the velocity is going to stay constant. So the distance traveled in the x direction is nothing more than this times the time. Okay. So you have your y and you have your x. And these are the two, this is the parametric equation for the x and the y. Okay? So the question is that there is a wall that is 400 feet away, a 20-foot wall. Will it clear that? So what you're trying to find out is at 400 feet away, what height is your y? In other words, if I hit the ball like this, okay, at 400 feet, is the wall here, or is it here, or is it here? So we need to find out what happens at 400 feet, okay? So what we need to do is we need to set, since we know that it's 400 feet, okay, so we know the distance that it traveled in the horizontal direction. So what we need to find is, using that, you find the time, and then plug that time into the y and find out the height at that point. Okay? So what we do is we're going to set the x to 400. So this will be 150 cosine 18 degrees t. Okay? So your t is going to be equal to what? Your t is going to be equal to 400 divided by 150 cosine 118. Okay, by the way, your book does not do this algebraically. I'm teaching you how to do this algebraically. The book just puts in its graph where it says that it clears or does not. Okay? So algebraically, this is how you would do it. If you do this, you're going to get about 2.8 seconds. 2.8 seconds. And if you put that 2.8 seconds into your y, you're going to calculate something that is less than 20 feet. It's going to be less than 20 feet. So if you put that y in there, basically going to be 16 2.8 squared plus 150 sine 18 degrees 2.8 plus 3. You get something that's less than 20, which means that no, it will not clear that wall. Okay? So that's how you would do this algebraically. All right? Again, you find the x direction, and you have the y direction. So you have x and the y, the parametric equation. You solve this for 400 because the wall is horizontally 400 feet away. So if then you go to 400, you find the time at that. So you find the time, then you plug that time into your y to find out what your height is. And this turns out to be less than 20 feet. Okay? So yes, the correct answer is it does not clear that wall. All right, next we'll do example number 10. Example number 10, we have the dreaded Ferris wheel question. Okay, the Ferris wheel question. Example number 10. Example number 10. We have Jane is riding on a Ferris wheel with a radius of 30 feet, as we view in figure 6.33. Wheel is turning counterclockwise at a rate of 1 revolution every 30 seconds. Okay? Assume that the lowest point of the Ferris wheel in the 6 o'clock position is 10 feet above the ground, and that Jane is at the point marked A, 3 o'clock, at time t equals 0. Find the parametric equations to model the path. Okay, so we have a Ferris wheel that looks like this with 10 feet clearance here, okay, and a radius of 30. Okay, so since where is this point going to be then? This point is going to be 40, correct? So the way to view this is to think of this as a circle like that with a radius of 30, because the radius was still 30, right? The radius was 30. And I just raised that up 40. So if I can find the parametric equation for this is nothing more than adding 40 to the y direction, correct? So the parametric equation for this is pretty simple. This is what? X is equal to cosine something theta, right? Something, so we'll call this cosine b theta. Y is equal to, well, it's not, it's 30 cosine, right? Because it's 30, the radius is 30. Y is equal to 30 sine b theta, correct? All right. So since we're using t, we're going to call this bt. Call this bt instead of theta. So I have bt. What is b? B is the period here. The period is, what do you have? Every 30 seconds, 1 revolution, right? So b is going to be equal to 2 pi divided by, well, the period is going to be this divided by b, correct? So b was going to be what? 2 pi over 30, pi over 15. So your b is going to be 2 pi over 30. This is b here, right? So you're going to get 2 pi over 30, so you're going to get what? So b is going to be pi over 15. So pi over 15 here, so it's going to be pi over 15t, pi over 15t, okay? So this guy is nothing more than, if I had the 0 used to be here, the center used to be at 0, 0. The center is now 0, 40. So I'm just adding 40 to that. So I'm going to add that 40 here to make that shift vertically up, right? So this here is the parametric equation for that guy. Okay? Find the parametric equations, model and find the position at 22 seconds into the ride. So 22 seconds into the ride, what is it? You're just going to put t is equal to 22 in here and plug and chug that, right? So put 22 in there, and you're going to get negative 3.14 and 10.16, right? Okay. Which, right? So that's all you do. I just plug those numbers in. T is equal to 22 seconds. Okay. Again, the hard part about this was viewing this guy as something down like that, and then doing the vertical shift up here to bring it up. Okay, and the period was 2 pi over b. Period is 2 pi over b. Right. So there you go. You get that. And that's that. And that's all we'll do today.